Hey guys, Mr. Lowry here. Hope you're having a good day. I wanted to run through this exponential functions review with you just because it's been a long time since we've talked about exponential functions. It was early March and now it's April. So let's run through this a little bit. This is going to be on your test that's going to take place. I think it's going to be next Monday or something like that, or Tuesday. But anyway, let's run through this a little bit and see if we can remember about exponential functions. Okay, so first of all, I want to just give you kind of like a template for exponential functions in general. Typically, we have something that looks like this. F of x equals a times b to the x power. Okay, and this guy right here represents the initial amount, or the amount at time 0 or something like that, starting amount. And this guy is either a growth or decay factor. Alright, and we know that if b is greater than 1, it's going to be a growth factor. If b is between 0 and 1, like it's a fraction or a decimal or something, it's going to get smaller and it's going to be a decay factor. So multiplying by something bigger than 1 makes it grow. Multiplying by something between 0 and 1 makes it get smaller. So when we're looking at this situation here, we have a bacteria colony, 650 cells, and then it's doubling. Okay, the initial amount is the amount of cells that you have to begin with, or the amount of cells you have currently if you're starting the time like right now. So let's say, this is current, right, and we want to start the time here. So right now, when no time has passed, current, whatever, this is kind of what we got going here. So this is the initial amount, 650 cells to start with. Okay. Now the growth factor is what you're going to multiply by, factor means multiply, to make this grow. So every hour it's doubling. How do we double something? We have to multiply it by 2. That's how we double. So don't think square, because that's not doubling. We're going to multiply it by 2. Okay. Now here's the kind of the where the power comes in, right? So multiplying by 2 isn't a power, it's just a regular multiply by 2. But let's say we want to know how many cells there are after, let's make a little table real quick, okay? So this is going to be number of cells, and this is going to be hours. Okay, so 0 hours have gone by, we got 650, right? If 1 hour goes by, we're going to take this and double it, which is going to give us 1,300. If 2 hours go by, we're going to have to double this, which is going to give us 2,600. Okay, so every time an hour goes by, we have to multiply by a 2. So if we want the amount of cells after 2 hours, it would be 650, the starting amount, times 2 for the first hour, and then times another 2 for the second hour. That would give us our 2,600. Okay, that's not what they're asking for right here, but that's going to kind of help us get started. So this is the pattern. Every time an hour goes by, we have to multiply by another 2. But repeated multiplication is just you can represent it with exponents. So another way I could write this is 650 times 2 squared, right? If I wanted the population after 3 hours, I just go 650 times 2 to the third, because I would have to multiply it by 2, and then by 2, and then by 2 again. Okay, so if I want the population after x hours, it's just going to be the population equals the starting amount times a bunch of 2's, right? How many times you multiply it by 2 depends on how many hours have gone by. If 3 hours have gone by, this is going to be 2 to the third. If 5 hours have gone by, it's going to be 2 to the fifth, right? If 10 hours have gone by, it's going to be 2 to the 10th. Because every time we go up an hour, we have to multiply it by 2. So we put an x here as a power to represent that we're going to multiply by 2 this many times. And remember, repeated multiplication is represented by exponents. Okay, so 650 times 2 to the x power, right? 650 is our initial amount, 2 is our growth factor, and then we have our power. Okay, what is the size of the bacteria colony after 3 hours? Well, there's multiple ways to get here. we could just keep our table going, right? So we could just do, 650 times 2 is 1,300. 1,300 times 2 is 2,600. What's 2,600 times 2? It'd be 5,200, right? But we can also plug it into our function. This isn't so far up that we can't do it just by repeated multiplication. We could just do times 2 times 2 times 2, right? So this would be like the third cell in our table if we wanted to keep going, right? We just keep going, or the fourth column, the fourth row. 1, 2, 3, 4. All right, so multiply by 2, we're going to get this 5,200. Now there's another way to do it. We can use our formula, right? So you could say, well, it's just going to be P equals 650 times 2 to the third power, right? And punch that in your calculator. 2 to the third is 8. Multiply that by 650, you're going to get 5,200 either way. Okay, so that's how many cells we got going on here, bacteria cells. All right, in the next one here, we have to take into account that the units are different, right? We're doubling every hour. So whatever our growth factor is in terms of, like growth factor is per hour, then the time needs to be in hours. So we need to convert this. So we know that 1 day is equal to 24 hours. Right? We don't want to just put it to the power of 1 because that's not right. That would be 1 hour. We want to put it to the power of 24 for 24 hours. So we're going to use our calculator for this one. P equals 650 times 2 to the 24th power. Now just because of the way exponential growth works, the 24th power is a very large number. So we're gonna definitely have to use a calculator here. We may have to use scientific notation as well. So I'm going to punch this in really quick. Comes out to be a really big number, but you can try it as well. Okay, and it's basically like in the 10 billions here. So it's like, maybe it's trillions. Let's see. So 10, 905, 190, 400. Yeah. So this would be 10 billion. Now if you punch it into your calculator, you might get something more like this. 1.09, etc., 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 times 10 to the 10th power. Scientific notation. So both of those are okay. You just kind of have to know what this means. If I want to change this back into this form, I go 1, 2, and I move the decimal place over 10 times. So this is rounded, obviously. But if I wanted to change this to scientific notation, I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? So it's 1.09 times 10 to the 10th. That's how many cells there are. So pretty dang fast. Doubling is a pretty fast growth rate. So I'm going to pause it there for now, and you guys can come back and look at the next problem set in just a minute.